from New York, it's Ask This Engineer.
Hey everybody, welcome to another episode of Ask an Engineer. It's me, Lady Ada, the engineer, and with me is Mr. Lady Ada, sometimes known as AdaBot, and we are here at the Adafruit factory. This is where we do all the design, manufacturing, engineering, testing, kitting, shipping, support, everything.
Laughing,
smiling, joyousness,
sharing.
Yeah. Love is created here at the Adafruit factory, and then we ship it to you in little black boxes. That's all we do here, but like right now what we're doing is a show, which we do every single week. It's called Ask an Engineer. What's on tonight's show?
I'm glad you asked. On tonight's show, the code is toggle. 10% off in the Adafruit store all the way up to 11:59 p.m. Off everything except for gift certificates and AdaBox subscriptions. Show and tell. Magical people around the world showing and sharing their projects.
And I wrote them down.
And she wrote them down. Pack of mailbags and stop by and read some of the emails you send us. We like nice emails.
Thank you.
Time travel, look back in the world of hackers, makers, artists, engineers, pioneers, people who did neat stuff. Made in New York City, some scenes from the Adafruit factory, Nimbus, the friendly IoT cloud entity, 3D printing, Raspberry Pi news, new products, I was promised a song. I'm going to answer your question.
You're going to get a song.
Yeah, trivia question, all that and more on, you guessed it, Ask an Engineer. Okay. Well,
I'm not going to sing the song yet.
Not going to sing the song yet.
I'm going to sing it later.
But we're gonna do things. First up, don't forget the code's toggle. If you want to know how we give all these folks days off benefits, 401ks benefits, pay time off for charity, all those things, it's when you buy stuff. We're a U.S. company. Look at this, Gothy flag.
Gothtronics.
We're going to change the flag to this soon. I'm putting in a request. Anyways, some logistic-y stuff. This is Ask an Engineer, 8 p.m. every Wednesday, Eastern Time. Show and tell, which you just did, 7:30. Same day shipping on checkout. Checkout before 11 a.m. Eastern Time if you're in New York City with a zip code that is in New York City. And we have same day, you have same day. And we have our free shipping deal right now, $200 or more for UPS ground in the continental U.S. Okay, Lady Ada, we had a fun show and tell tonight. We do this every Wednesday.
That's right.
People show their projects, something that's important to them. They share it with you.
Yes.
They put it on the internet.
Yes. We see it with our eyeballs. Actually, it's interesting, the show and tell. I'll say something. This is the future. You know those old AT&T commercials? They're like, oh, the future, and like, you will. This is the future. Like,
we are.
10 people from around the world sharing and showing off the project that they've built.
That's right. We're not wasting jet fuel. We're not flying.
I'm not paying $1 a minute anymore for AT&T long distance.
Okay.
Start off with Noah and Pedro. They have a really cool new tutorial this week. It's not 3D printing, but it's kind of like what you do if you don't have a 3D printer. It's how to hack a Mattel Halo sword that they got at ThinkGeek. And they remade it because the original came with only 11 LEDs, and like, it's totally lame. You should have at least 80 LEDs. So they kitted it out with a trinket and NeoPixels to make it like way blinky, and it looks really cool, but they kept the battery box and the sound effects. So it sounds as good and it looks really good. It's just really bright now, and it has like a really neat like shimmering effect, just like the game. John Park came by and showed off his freefall deck. It's this week's project. It's another Circuit Playground project. This time it's using the accelerometer to detect when a deck of cards is dropped. So he's been doing, when we first talked to John Park about the projects he wanted to do with Adafruit, he was saying he'd been spending a lot of time making escape room projects with his friends who run an escape room in LA. So we're like, let's just do a bunch of projects that are escape roomy, like little tricks and like gags and pranks and like sneaky devices. So this is a pack of cards that when you drop it, it detects that it's been dropped, and it plays a Morse code message. So that's kind of neat. It's also a really good tutorial on how to hide things inside of a pack of cards. Apparently, it's a good technique if you do magic or trickery, because you can make it look like it hasn't been opened. C. Scott came by, talked about, he just did a release of CircuitPython 1.8.3, I believe.
You mean regular Scott, not C. Scott.
Sorry, what did I just say?
You said C. Scott.
Sorry, there is also a C. Scott. I meant Scott Shawcroft.
SS.
S. Scott.
Yeah.
So many Scotts. Sorry, I meant
great
Scott
Scott.
S.
They're all great Scotts, too.
They're all great, but I meant Scott S. I apologize, Tan Newt, for mixing you with C. Scott. You're not. I know the difference between you.
So many Scotts, not enough time.
I know. So he had CircuitPython 1.8.3. And he's also made a custom travel keyboard that he's designed in KiCad. So he showed off the custom keyboard, and he had like a feather slot for it. And he and I worked on a Circuit Playground demo. So we actually wrote Python code to test every element of Circuit Playground today, which was really handy because I wanted to test a bunch of Circuit Playgrounds really fast. And it was really fast to do it in Python, faster to do it than in Arduino because you just double-click, drag the file on, and it's testing. Carter has a new tutorial. He previewed the tutorial he's going to be writing. It's Simon for Circuit Playgrounds. Remember the old like 80s game Simon? Did you own one of those?
Yes,
I didn't.
I did because I was an only child and I was by myself a lot. It's one of the buy yourself toys.
Did you win?
It was a terrible time, so I don't really remember winning.
Okay. Anyways, so
No, I don't remember the joy of like, oh my gosh, I beat Simon.
well, it just like beeps like 4 times.
Yeah,
Anyways,
it's not a triumph.
Carter found a.
Look, you asked. Don't ask.
I have to keep it conversational, so it's not
Yeah.
just me talking the entire time.
Yeah.
Anyways, he went online and he found a page where somebody like reverse engineered all the timing and the tones and like how long it beeps
Yeah.
and like the.
It's like an emulator almost.
He basically made an emulator.
So you can play with the touchpads. On Circuit Playground.
Yeah.
Simon.
And I like how it's divided into quarters, so it's like 3 LEDs light up, but you can really play it. It has the exact same beeps. And it's funny because it's a piezo beep, so it's
And
like
then someone on Tindy just posted a Pong game with Circuit Playground. This is working out great.
Sweet. Okay, so Circuit Playground, Simon, and then and the reverse engineer page. The reverse engineer page is like the coolest thing. We're gonna blog that tonight. I know what we're doing tonight. I'm gonna blog that.
We're gonna blog
Simon.
We're gonna blog a thing.
That's what married couples do.
Yeah.
Okay, and then Richard A. Had a local MQTT server that he runs on a Raspberry Pi, and he's using Huzzah. He basically tried to replicate a lot of the Adafruit I/O MQTT stuff, but localized. And he's also using TVGON for TV control. He'll come back and talk more about that. Roberto couldn't make it to this Monday in San Antonio. There's a gigantic Martin Luther King Day march, and he couldn't make it out. But what he did do is he printed out 3D models of the Martin Luther King monument.
Yeah, it was
the
cool.
monument of him, and he turned them into walking sticks, and he gave them away to people because it's the Creative Commons. So it's like he kind of had the spirit of Creative Commons. Like, okay, let's just make these cool walking sticks with this like bust on them and give them away, and people really loved them. Some kids from UT ended up taking them. Mia and Caddy the cat showed up, or Katie the cat. They have a YouTube apparently, probably have like 5 million subscribers. They found the cat in September, adorable yellow tabby. And Mia also built a Snap Circuits fan circuit. It's cool.
Yeah.
And launches his fans into the air.
The cat likes it.
And the cat likes it. So
Yeah. Okay.
good. And then C. Scott, last but not least.
And
Jason. Jason built a mini rover Bluetooth kit from Adabox 2, so he got that working, so that's cool. And then C. Scott, because I've been working on learning digital signal processing, because I don't know anything about it, got to relearn all that stuff. He showed off a hand-etched hardware digital signal processor that did it all in like, there's a Lattice CPLD and like all this like hardware circuitry that did the signal processing because there's no DSP chip. So he did it all like with logic gates and CPLDs and stuff. So
Okay.
hopefully, he's like, well, he looked like he did it in like the 90s, early 90s maybe. So if
Hand-etched.
you can do that then, hopefully I can get my PDM microphone working.
Okay. All participants on the show and tell get an As Seen on the Show and Tell sticker. If you were on the show and tell, email support@adafruit.com, and we'll send you out As Seen on the Show and Tell sticker. We do that every week. That's the highlight of the week. We've met so many great people. A lot of them end up working with Adafruit in
Carter
some way.
Nelson we met on Show and Tell.
Yeah,
and now
he recently
tutorials.
visited. He gave me a really nice pin from the Living Computer Museum, and now I'm starting to collect pins because we've been doing it with Adabox, and so we have pins. So it's a nice thing because you can, if you just wear all black all the time, a pin is a nice accent.
It does.
Yeah.
It's a nice accent.
Okay. Next up, this is all part of our Adafruit Live series. I just wanted to mention this. We hit a interesting goal last week. So last week, when we were doing our live broadcast, we hit 1,160 peak concurrent viewers all at once, and that was a big deal. Lots of like media organizations and YouTube and all the like video awards things, because we don't take sponsorship and we don't have brands that we interact with. We don't get like awards for like
Brought to you by
teaching
T,
electronics.
yeah.
Like there's like the shorties and all that. Like we'll never be part of it because we don't
No,
have
because
it.
I don't have Ashton Kutcher showing up.
Yeah,
and,
we don't
like,
do that.
Promoting a movie.
But what we do is have a real fan base and real community. So thank you, everyone. It was kind of neat
Yay.
to see that. Yeah, we were told by YouTube the algorithm doesn't recognize folks like us because like the thumbnail doesn't have like you in a bikini or something like that. Like that's how you game the system if you want to have like your videos go viral and stuff like that. But anyways, thank you everyone because we know you're watching. Thank you. Okay, next up. Decibel 88, we did a bunch of stuff this week.
Oh, yeah.
On Decibel 88, you're exploring, like you said before, all this digital signaling. So not only did we have a microscope on Decibel 88, but we also had the entire overhead as the backdrop. So check out some of those. You can see us do the circuit playground tester. You can see us use the microscope, and you can see you kind of go through the whole process. I like when you use the plotter inside of the Arduino IDE, which not a lot of people know about, to show like all of the data that's coming in as you were working on this microphone.
Yeah, so
super cool.
if you're interested in PDM microphones, I2S microphones, and like how to do digital signal processing in Arduino, or how to get started, because I didn't finish it, but I got started with it. I have some streams about PDM microphones. I never used a PDM mic before, so pulse density modulation. So we have a couple streams about that.
Yeah.
And hopefully this weekend I'll wrap it up and get some. I'm now reading a book about digital signal processing so that I can write the code that will then hopefully we'll have a stream and I'll have like beautiful audio coming out of it.
Yep. Okay. And next up, Tony D did I think the best what is CircuitPython video. 1 hour, has everything. I sped up here so you can see kind of an overview in 30 seconds. He used all the boards that we're working on, so a lot of this was it's not out yet, don't ask type things. But he had each board. We have the purple prototypes that we're using, and he goes through CircuitPython, why we made it, CircuitPython, what it does, CircuitPython, all the interesting things that go along with helping people learn electronics with Python. So check that out. And one of the neat things that's coming up soon is you'll see more and more CircuitPython stuff. So this is our little logo that we got for CircuitPython. And this is Blinka the Snake. Helps you learn Python, electronics. There's Blinka in front of a computer. Snakes love using the internet.
You know what's funny is, of course, Blinka can only use the mouse. Cause I guess you could poke each character at a time.
Yeah.
Is it the tough part about having like a armless, legless?
You can use the mouse.
You can use the mouse.
Yeah.
And can
click. Yeah.
Click one key at a time.
Apple mice only have one button anyway.
That's true. Good point. Good point.
Yeah.
Perfect for the Apple mouse.
Okay. And then for the folks that are really interested in CircuitPython, we have a hack chat with Hackaday next week, Friday, the 27th, around 3 p.m. Eastern Time. There's a chat register on hackaday.io and check it out.
Yeah.
So we'll be doing that. Tony and Scott and you will be there. And I'll be filming our part behind the scenes here. But do check it out. Okay. Next up, John Park Makes, John Park's Workshop, the Mystery Box video. Take it away.
Morse code message hidden within a deck of cards. Who would have figured? I'm John Park for Adafruit Industries, and this is the Freefall deck. Now this is a type of mystery box that you can use in an escape room, or perhaps for a magic trick, scavenger hunt, what have you, where your participants are given a deck of cards through some sort of clue. Now they've been instructed to keep the deck with them at all times, and to make sure that the dealer doesn't think they've been marking their cards, so they need to leave it sealed. A further clue will tell them that they need to toss the cards. Now, your astute puzzle solvers at some point will probably figure out that they need to literally throw the cards, either up in the air and catch them, drop them onto a soft surface, perhaps throw them from one participant to the other. And when they do this, the deck will go into a free fall, and an accelerometer running on the circuit playground inside will detect free fall and then give up the Morse code message by beeping. There are two key things when building the free fall deck. One, we want to get inside of the cellophane without it appearing like this has been tampered with. And two, we're going to build a circuit playground and battery-based circuit as well as an insert so that it matches the weight and feels the same as a deck of cards inside. I recommend using a hobby knife and a very small flat piece of metal to help lift up the seam at the bottom. There is a small flap that can be lifted up, and I like to start the cut with the knife and then, to avoid cutting it further, use the metal insert to carefully pry up the plastic. Now, the way these are usually sealed, you will need to cut the end that doesn't have that fold. Okay, and now we've got the cellophane out of the way, so what I'll do is repeat this procedure on the cardboard flap that seals the case. And we're in. Now you can remove the deck of cards and set them aside. We will actually use a few of these later to pad out the box so that our fit is exact. We're going to use this circuit playground to detect freefall and to play back the Morse code message. The circuit playground has an accelerometer built into it, and with some software uploaded to the circuit playground, it can detect when freefall has been achieved. Now, we can do anything at this point, blink lights, run motors, whatever you have hooked up to it, but for our purposes, we're going to use the small built-in speaker to beep out a Morse code message. Again, that's been uploaded to it in the Arduino IDE, and you can download all the code for this and then adjust the Morse code message as you like on the tutorial page that accompanies this build. I'm using a little 500 milliamp battery, a LiPo, and when I plug this in, it is now ready to detect freefall. And the nice thing is this is fairly immune to casual inspection. If someone's checking it out, moving it, it's not so sensitive that it's going to start beeping until they've figured out that clue that they need to toss the card deck in the air. It begins to go through the beep pattern of the Morse code message. Now, you could absolutely get by with wrapping up the circuit inside of some paper and maybe putting in some coins or something to estimate the weight that you're going to need, and then put some cards on either side, slip it in, and it'll work pretty well. One of the first things I tried was taking a little piece of wood to the bandsaw and cutting out a circle to fit the circuit playground, and then fitting this and the battery along with a few other scraps of wood inside the box. And this works pretty well, but the weight was a little bit off and the feel wasn't quite right. So what I did was used some calipers to measure the cards that we're going to be replacing inside of the case. And then I also used a very small digital scale to find out the exact weight. Then I designed a template inside of a CAD drawing program to laser cut some acrylic that gave me almost an exact match on the weight and size. Here's how I assembled the final layers of acrylic. I have a base, then I'm going to go ahead and plug in my circuit playground and battery, and I can fit that into these little cutouts. And then I have another to place on top that leaves room for still plugging in the USB in case you need to change the software on it at some point. And then my next piece has a cutout for the speaker to help the sound get out. We didn't want to muffle it too much here. And finally, I can cap it all off. Now, this comes to within about 8 to 10 card widths of the exact size. So I went ahead and grabbed a few cards and placed them on the top and the bottom until I had an exact measurement. Okay, there we are. Now I'm going to go ahead and close this up and reverse the procedure. So we're going to place a little bead of glue across the cardboard flap that was previously glued down. And what you'll want to do is set this up maybe a few hours before your event or the illusion is needed. The battery lasts a good day or so plugged in, so you shouldn't have to worry about it too much, but you also don't want it dying on you before the moment is needed. Let that dry for a moment and cool off. And then you can either use some hot glue, but you want a very, very thin piece of it. Some blobs might give you away on the cellophane. Or you may want to try out some super glue or another thin glue. And there we have the free fall deck. It is now ready to be deployed along with your clues so that the participants will go ahead and throw this in the air and then be amazed by the Morse code message coming from within. On page X. Interesting. I'm John Park for Adafruit Industries, and this is the free fall deck.
Okay, Mailbag.
Dapper.
Every single week we read these at our all-company meeting called State of the Fruit, but we also read them to you. This one is from someone else named Phil. I like people named Phil. I don't have a particular suggestion for the blog. I just wanted to write and give you a huge thank you for your awesome site and fantastic products. I now have 11 Raspberry Pis and too much Arduino to count, all doing different things. I've never been so much into electronics, but your products have definitely changed that. Thank you again very much. Yay, thank you. That's nice. Thank you, Phil. Okay, next up, time travel. We look back in the world of makers, hackers, artists, engineers, pioneers, and more. This is neat. Happy birthday, Anita Borg. American computer scientist and academic is born. There's an Anita Borg Institute, and then there's the Grace Hopper Celebration of Women in Computing. And every year, check out the Anita Borg nominations because you always see some amazing women in tech. Also, speaking of, because we have some very cool folks in this is our anniversary of our coloring book. So in 2012, we released Lady A to Z is for Electronics.
Wow, really? Only 2012?
Yeah, and what was neat is Maya had a printout and she was coloring the coloring book. We released it as a Creative Commons, and lots of schools use it, and lots of people around the world print it out and use it, and they learn electronics based on the letters of the alphabet. And we use that as our script for Lady Ada's series called Circuit Playground. We're up to K is for kits.
Next is L is for LED.
Yeah.
You know, that's going to be Blinky.
Yeah. Okay.
Cool.
Okay, open source hardware news. I just put a bunch of stuff in this section. Usually, Lady Ada, there are 1,147 tutorials in the Adafruit learning system. What is new this week?
Okay, so this week we've got the new guide from Knowing Pedro, the Halo Energy Sword remake. So it's a Mattel sword that they've remade and upgraded with lots more LEDs. We've got the mystery box, which you just watched the video of, from John Park. And we've got a little bite-sized tutorial from Phil B. The Adalite project, one of the first projects that he worked on at Adafruit, was basically turning an Arduino and some processing code into a TV backlight, like the Philips, what was it called? The Hue lights? Not the Hue lights. They had like these they had TVs that had lights in the background. Yeah. Anyways, I don't remember the name of it because it's like not used that much anymore. But so we made it, and this time it's made with a Circuit Playground. So you plug your Circuit Playground into like your laptop, for example, and you plug it into and you stick it onto the back with some double sticky tape, and then it illuminates the back of the wall to match what's on the screen. So it has a really nice effect, and it kind of makes the TV image kind of blend into the wall a little bit more.
Okay.
Very cool.
All right, so check out those, and that's learn.adafruit.com, and you can peruse the 1,147 tutorials.
Okay, so close to 1,150.
Getting
I
close.
remember when we got 1,000, and already we're like more than 10% of the way towards 2,000.
Yeah. Here's something neat. Remember when we had the chairman and the CEO of Radio Shack? Well, we ran into them randomly at a Radio Shack in New York City earlier in the week, and we took a photo. Circuit Playground and our ProtoShield is in Radio Shack.
Yeah.
And you can see both of those, and just go to the Maker section in the STEM section inside of Radio Shack. So we know for sure the ones in New York have it. So there you go. Okay, next up, Maine, New York. This week is a little different. I got an extra special thing this week.
Okay.
So it was announced that Twitter is getting rid of Vine, our incredible journey. Vine is going to spend time with its family, I think. But they are sunsetting
Back
whatever.
in Vineland.
What?
Back in Vinland.
Yeah.
Vineland.
So they said we're getting rid of everything. So you got to get your stuff if you want it.
Yeah.
And so we downloaded. I think it's 4 years worth of Vines from our Adafruit Vine account.
Yeah.
And then I uploaded it to our video backup that we have. And then I also put it on YouTube. And it's just a bunch of tiny clips from the last 4 years. So it's 41 seconds. So you can watch the last 4 years of Adafruit. We didn't use Vine that much, but you'll be able to see all the way back from when we first started becoming like a factory and a company. So here we go.
Okay. Speed it.
So it's kind of hard to keep up, but there's 3D printing. That's when we're on the third floor. There's NeoPixel. You were an event. There's
some demos.
There was we had a hat, and then we started these manufacturing clips.
Selective solder tool.
Woo! Some fireworks. Some more. We got the selective solder machine.
And how much is it sped up by? Like if you were going to watch all the Vines at once, how long would it be?
I don't know, like hours. And it's a lot.
It's a lot of 6 seconds.
Yeah. So, anyways, that's it. All of the Vines. So we downloaded them. And then we have some other stuff. This is some footage from the factory here. This is
Prototype
circuit playgrounds.
So they slowed them down when you picked them up. Yeah, these didn't come on panels, so we had to put them. We had to put them on the mesh.
And then here's the selective solder machine.
Looks like it's making motor shields.
Yeah. Meet. So
It
that's
is a lovely tool.
Yeah. So that's doing all the normal manual soldering that we'd have to for through-hole parts using Robot Friend. That's what the computer sees. And then underneath the board is when it does its soldering.
Yeah, neat.
Cool stuff. Okay. Some IoT news. This is Nimbus, the friendly cloud entity. We're still in beta for Adafruit IO. We'll probably be out of beta soon, but we have a couple updates. First one is the user interface update. So check out this post from Justin. He's the lead engineer on this. And they have an all-new Adafruit IO user interface. Check it out. Faster, more responsive, all the things that you like about IO, and then some.
More.
Yeah. So that's a post. And then also check out the state of I/O. Right now, we're up to 70 million inserts of log data in the last 7 days. 21,000 users, getting close to 22. 16,000 online feeds. 57,000 feeds total, because I guess that's since the last time.
Like I have
we
10
did
feeds
stats.
I don't update.
Yeah. 110 inserts per second via MQTT and 12 inserts per second via the REST API. Cool stuff. Don't forget also, we have the Internet of Things Bill of Rights. If you want to participate with that, it's on GitHub. Let's make the world a better place for things and the internet. Okay, 3D printing. Noah and Pedro were on the show and tell.
Yeah.
They talked about that toy upgrade. We have a video.
It's cool. It's really bright.
In this week's project, I'm going to show you how you can upgrade this into this. This is, of course, the infamous energy sword from Halo. This cosplay prop is actually made by Mattel and officially licensed by Microsoft. You can find these exclusively at GameStop, and I think it's actually a pretty decent piece of kit. It does actually light up, but it kind of leaves a lot to be desired. It only has 11 LEDs, so the lighting in this thing is kind of underwhelming. So in this project, we're going to tear it down and add lots of NeoPixel LEDs. The two blades are joined together with brackets which make the whole piece sturdy enough to swing around. On the back of the handle lies the cover for the batteries and a power switch. It features different modes which can be toggled by flipping the switch. And behind this grill is most likely the speaker. A trigger button fires off the LEDs and sound effects while in a specific mode. I started off by removing the battery cover and then removing the batteries. After that, I started removing all of the screws in the handle. I also removed the screws from the mounting brackets which hold the blades to the handle. The mounting brackets are in two halves that can easily be separated. Then I lifted the handle off the bracket and separated the two halves of the handle, and here's all of the electronics. On the main board, I found two connectors. These are actually the wiring for the LEDs. They were really easy to unplug and disconnect from the PCB. I then unraveled the wiring from the handle and started removing the LEDs. On one of the blades, I found a tilt switch. This is used to trigger the LEDs and sound effects when it's swung around. Next, I needed to remove a bit of glue from the inside of the blade. I pried off the bracket from the blade and carefully removed the inner plate. This clear piece of plastic has engravings and gives that blade that edge-lit texture. The outer shell of the blade is completely hollow and in one piece. I then removed the tilt switch from the bracket by clipping the standoffs that held it in place. It's soldered to a standalone PCB and has separate wiring, so we should be able to reuse it. So I then separated it from the LED wiring. Next, I started removing the LEDs from the bottom of the clear plate. This required some snipping since they are fixed in place. Once the LEDs were removed, I proceeded to detach the bottom piece from the clear plate. This would prevent the NeoPixel strips from fitting into the blade, so that's why I removed it. To sort out the power for this project, I put the batteries back in and turned it on. Using a multimeter, I probed the pins on the PCB to see which were power and ground. After I traced these two, I proceeded to remove the PCB from the handle by removing the two screws. And on the back of the PCB is the main switch. I was happy to see some labels here, which helped me verify all the pinouts. The trigger button is also mounted to the PCB. I then traced the pinouts of the trigger button. I'll use this to cycle between different animations for the NeoPixels. An Adafruit trinket fitted nicely in an empty spot on the handle, so here's how I'll wire the power into the trinket. I'll connect the voltage and ground from the PCB to the pads on the back of the Adafruit trinket. I then cut up two pieces of wire and used a pair of wire strippers to remove a bit of insulation. I tinned the exposed tips by adding a bit of solder and wired them to the power and ground pads on the back of the Adafruit trinket. Then placed the trinket into the handle and started connecting power and ground to the corresponding pins on the PCB. I put the batteries back in and did a quick power test. The trinket powered on and we should be able to power up to 2 NeoPixel strips using the 3 AAA batteries. I grabbed a strip of NeoPixels and started measuring how long they needed to be by lining them up with the blade. I was able to fit 43 NeoPixels per blade, a total of 86. So I cut up the strip using a pair of scissors and removed the connectors on the end. The sheathing didn't allow the strip to fit into the blade, so we won't need it. These flexible breadboard PCBs are awesome for these projects that require a lot of power and ground connections. And since there's only a few on the trinket, a small piece will go a long way. I proceeded to tin the pins on the flex PCB by adding a bit of solder. Then I connected a short wire to one of the pins. I connected this wire to the ground pin on the Adafruit trinket. Next, I can work on the connections for the trigger button. I'll need 2 more wires, one for ground and the other for signal. Connected one wire to pin number 2 on the Adafruit trinket and the other to the ground on the flexible PCB. Then the trigger pin on the switch PCB to pin number 2. I also connected the ground wire here. I put the PCB back into the handle and fastened the 2 screws to mount it back into place. Next, I started working on wiring the power to the flex PCB. I connected a wire to one of the rows and wired that to the 5V pin on the Adafruit trinket. I repeated this step for the NeoPixel data connection, wiring it into pin number 0 of the Adafruit trinket. Now I can work on connecting the NeoPixel strip by cutting some longer pieces of wire. I stripped, tinned, and connected them to the 3 pads on the NeoPixel strip. I made sure to wire it to the correct direction, going through data in. Then I fitted the blade by inserting it in through the opening. I slipped it through the whole blade and put it off to one side. I grabbed the clear plate and fitted that back into the blade, making sure to avoid dislodging the NeoPixel strip. I then carefully popped the mounting bracket back into the blade and made sure the wiring was kink-free. The tilt switch fit right back into the bracket as well, I just needed to add some mounting tack to hold it in place. I reassembled the mounting bracket for the blade and fit the handle back by laying it over the corresponding standoff. The wires fitted nicely through the harness on the handle and I proceeded to connect them to the flex PCB. I connected ground to ground, power to power, and data to data. A piece of mounting tack will secure the flex PCB to the handle. I repeated this process for the second blade and started reassembling the mounting parts. A piece of tape helped keep the wire secured and contained within the handle. And that's pretty much all of the wiring. Now I can go ahead and close up the handle. I put the remaining bracket back onto both of the blades and secured them to the handle. Flipped the whole thing over, and now I can start inserting all of the screws back into place. And lastly, I fitted the two blades back together and fastened the last remaining screws. Finally, I flipped the switch and gave it a test drive. So the code used in this project is from the button cycle sketch from the Adafruit NeoPixel library. For a full tutorial on how I built this project, check out the learning guide linked in the description. I'm really impressed with the design of this prop, and I'm surprised how hacker friendly it was. This could definitely be modified to have even more functionality. This was a fun project to work on, and I hope you gained some insights on how you can upgrade your projects. Hey, if you like this build, let me know by giving it a share and a thumbs up. And if you want to see a fully 3D printed Halo Energy Sword, check out the video linked in the top right card. Thanks so much for watching, and for more DIY projects, be sure to subscribe to the Adafruit channel. Also, don't forget to check out the playlist for past projects.
Okay, and don't forget, No Pedro's 3D Hangout is on Wednesdays now, and they just did one today. It's uploaded to YouTube automatically.
Cool.
So you'll be able to watch it after this show if you want.
Yay.
And then we have a time lapse. These are my favorite because 3D printing, no matter what, will always take a while. So you can speed it up, and it's very satisfying.
It is.
It's like
Very
almost like a
satisfying.
transporter.
Yeah.
We have some Pine news this week. The compute module, which you know about, was released. Why is this different?
So the compute module is going to upgrade. The original compute module was basically the same as a Raspberry Pi 1, but in this like adorable little dim shape. It's like it's a memory stick shape, so you can get sockets for really cheap, and it's really easy to snap it into a socket.
Yeah.
But they've updated it. It now, instead of coming with the original BCM chip, it now comes with the upgraded one, which is like the A7 processor, I think is the A7. It's the one that's in the Pi 3. So you get quad core, I think like 1.2 gigahertz per, you get a 1 gigabytes of RAM. So it's the latest and greatest Pi 3. There's two versions. There's the standard version, which comes with 4 megabytes of MMC flash, so you don't need an SD card. Actually, it has a flash built in, so you can just load Jessie Lite onto it. So that's really handy when you want to minimize your external components. And then there's also the Lite version, which use an external SD card slot with. So it has a little like dev board. We'll probably will carry this once these are available for us to purchase, because we carried the original compute module before it was discontinued. But what's like the NEC monitors, there's these big monitors for digital signage that have a compute module slot. So if you want to like,
That's smart.
if you're doing like industrial or like you want to use the compute module on a product, this is where you should go. Like instead of getting a whole Pi 3, you snap this in and then you just use whatever connectors you want and you bring them to wherever you want. So you can make your own custom devices that are powered from Raspberry Pi. So it's a really good option for industrial use or when you're in manufacturing. Makers probably don't want to use this unless you need to make something as powerful as a Pi 3 but as small as a Pi 0. And you're willing to solder like 168 pin sockets.
Okay. So the question that came up in the chat before was, when it's available, we'll probably stock it, right?
When it's available, we'll stock it. I don't believe they're shipping yet to distributors.
Okay. All right. Hey, Data. Before we...
I'm getting ready.
I know. Code Toggle. If you want to support an open source hardware company like Adafruit, use the code Toggle. That gets you 10% off in the Adafruit store. That's the best way to show that you care. Okay, well, let's do this thing.
Yes. New, 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 new.
did it.
New.
Okay. All right. Well, first,
Time for new.
the code was toggle, and the reason is, well, we have these toggle switches.
These are toggle switches. So we've already carried the red and yellow toggle switches.
Toggle switches.
And you might be wondering,
Toggle switches.
Lady Ada, why did you carry red and yellow,
Toggle switches.
and then you went and got green, blue,
Toggle switches.
and white? Well, there's actually a really good reason.
Toggle switches.
The original samples I got had
Toggle switches.
clear LEDs, and they were really, really bright.
Toggle switches.
And they were actually too
Toggle
bright
switches.
to use. So, like, they would blind you. So I actually went back to the factory and
Toggle
said,
switches.
hey, get me versions of these toggle switches, but with diffused LEDs in the ends instead of clear ones, because the red and yellow ones came with diffused.
You don't want to be blinded by your switches.
No, they were like blinding. They were
Okay.
so bright. I could
show
go
me
grab
later.
them. Maybe I'll show them later. But
Okay.
so
Let's show them
the
later.
new ones are nice and diffused. So this is a sample. Let me back this up a little bit. So I have it set up so when it's flicked on like this, it's lit, and then when you turn it off, it's off.
Toggle switches.
But you don't actually have to do it that way. You know, you can actually make it so the LED is always on, and then you can, use the toggle switch by connecting between these two pins. Anyways, so it's really nice. It's got this nice diffused LED at the end, which
It's a
isn't
nice
blinding.
sound.
It's really clicky. You can actually remove this. This is screwed on, so you can just remove this if you don't want this part. But it's really lovely because it's got this nice
Click,
LED.
clack.
And I'm powering it from a coin cell, but you can actually use up to 12 volts. There's a little resistor inside, so you can theoretically power this up to 12 volts. It'll get brighter, but it won't it still won't be blinding. So this is green, so it's a nice diffused green. And then I've got blue. So got that nice diffused blue LED at the end. Same deal. You can have the LED on all the time, or only on when the switch is on. And then when you close the cover, it closes. So this is really great for making control panels, or I don't know, something fun. And then finally we have white. So we already have red and like orange yellow. So this kind of completes the collection. So this is the white diffuse LED with a clear top. And there was purple, but it was like really ugly. And there was also like carbon fiber, and it was really ugly. So these are the only three that passed muster. So we've got red, white, blue, and then yellow and red as well. So a nice collection of lit toggle switches.
Yeah, there's a bunch of crappy ones out there, but you won't find them in the Adafruit store. We only have the ones that are really good.
And by the way, everyone else has the clear LED ones for the like green, blue, and white. I actually had to custom order the diffuse type, and they were like, why would you want that? And I'm like, so it doesn't blind you to death. And they're like, we don't understand, but okay. So it took me like 3 months to get these versions with the diffused LEDs, but I think it's worth the wait. Worth the wait.
Toggle switches.
Thank you.
Okay.
So that's toggles.
Okay. This is fun.
Next up,
We just put this in the store today. Super cute little LED sequence.
we have LED sequence, which we've carried for a while, but
Yes.
now we have them in a
Look at the
rainbow
video.
pack.
Look at this video. Look at this video. Look, 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 look. Beep.
I have something
beep,
better than that.
beep,
I've got a
beep,
live
beep,
demo.
Beep, beep. Yeah.
Yeah.
Okay, let's do a live demo.
Let's do a live demo. They don't blink individually, but so this is red, pink, which is also a little yellow, a little orangish pink, white, emerald green, and bright blue. So a nice range of colors. They're very bright. You can sew them. For here, I just soldered them onto some wire to light them up, but they're meant to use with Gemma or Trinket or Flora or Circuit Playground for sewable use. Although, of course, you can always just solder a wire to them. If you just need a very small LED with a built-in resistor, these have resistors built in. So they're handy for little jewelry effects. I think we had somebody like put them in like eyelash to make it, like a blinking makeup.
Can you power them all from the pins on the side at the top? Like, how
on
do
the
you?
side?
Yeah.
Well,
Can it power them all from the pins on the side at the top?
that I don't know what side top, but you can power them from GPIO pins. I'm just being lazy right now and powering them all up at once from the power pins.
Okay.
But like if I connect this to like pin 13, I can like
Beep.
you
Beep, beep.
can power them from a GPIO pin. This is just pin 13 blinking, but normally you'd have like one per pin, for example.
Okay. All right, next up, we have last product design. Is it? This is the Espressive
Rover.
Rover.
Yeah. This is, we just got these today. So this is the ESP32 Rover kit. It's a dev kit by Espressive for people who are developing with the ESP32. It's got a lot going on.
Okay.
So this is the back of the board, and I'll explain what you get. So this is the ESP32 module, and it's got an FCC ID on it. So they did get FCC certification recently, so that's cool. So you get FCC certified module. Crystal capacitors. This is an SD card slot, so you can load files on and off. There's an RGB LED, not a NeoPixel, it's actually RGB separate. 4 indicator lights over here, just plain LED lights. There's an FTDI FT2232. This is used as a JTAG interface, as well as a UART connection, so you can do debug and program if you want to program it and also use the debug capability. This, I don't know what this is. This is 93C64. I think that's an I2C EEPROM, I think. This is a regulator. It's got some buttons. You can power it from external DC or USB, so let me just do that. And then the best part is on the back, there's a gigantic 320 by 240 LED display, and when I turn this on, oh, sorry, I have to turn this on too.
On and then on.
Yeah, on and on.
You have to turn the on switch on.
I know, yeah. So there's a little calculator, demo, and then it has some squares. So I think it's probably an i-Line 9341 compatible. Hold on, I keep not turning this on. There you go. Squares, calculator, you know, thing. Anyways, so you can use this for. It doesn't have a touch screen, but it does. You know, you can probably use our Adafruit graphics library, i-Line 9341 library, and there's also a bunch of GPIO pins. So if you want to connect to the pins over here, you can get to all the pins. So it's kind of like a ready-to-go dev kit for like all sorts of craziness. I mean, it's got pins on this side and the TFT on that side, so you can make interfaces that use the Wi-Fi or Bluetooth. ESP32 core is still being worked on. I think they released 1.0 of the API, but I think they're still going to be releasing more and more. So this is a good kit for people who want to develop products or devices with ESP IDF, and probably this will work with the Arduino core as well.
Okay. All right. Any data. That was it. You did
Yay.
it. Yay! New products is over.
Great.
Okay.
We have time for
So
questions.
yeah, we do. We will do that. But first, don't forget the code's toggle. The things that are in stock that are in the store, use the code toggle. You can use it for toggle switches. 10% off in the Adafruit store all the way up to 11:59 p.m. Eastern time tonight. You should do it. Post up your questions in the chat room.
Okay, while you're getting a couple questions, I'm going to look really fast to see if I can make these.
Okay. I'll just scream the questions over to you.
No, I mean, in a moment.
You're going to be there in a moment?
Yeah.
All right.
One of these boxes. Yeah, it's okay. What's the question?
You have any suggestions for how to connect a Arduino and that weather station shield that will allow someone to send weather data over APRS, ham packet radio?
Well, you'll definitely want to get the APRS stuff working first, but then, whatever data you get, you just packetize and send it. I've never done APRS, actually. Okay, so here I got this switch I can show. I've never done APRS myself, but I think there's like probably ham radio shields or connections or something that you can use, and then you just send the data. Okay.
All right. Someone's looking for maybe the next thing after Snap Circuit for kids. You might want to try Makey Makey. If you're
Makey Makey's good.
Yeah, that's a good one because it turns anything into a keyboard.
Yeah.
Some other things that were suggested, little bits, Lego Mindstorms.
Yeah.
And things like that. Okay.
Okay, can I show this really
Yeah.
insanely bright?
Insanely bright.
Insanely bright.
A lot of people who work at Adafruit are insanely bright, I think.
They are.
But you're talking about luminosity.
Yeah, so this is 3 volts, but because it's not diffused, I think this is the non-diffused one, right? Oh no, actually, what's funny? I scratched this with some sandpaper to diffuse it. It was just like a point of bright light. Maybe I'll find a version that I didn't do that too. Yeah. Anyways,
Okay.
this is the previous version. So I sanded it and told the factory this is what I want it to look like.
Okay.
Yeah. Okay. What's the next question?
Next question. I can do this one. Any chance you guys might start making waterproof Arduinos and parts? I think we wouldn't make something specifically called waterproof, but there's lots of things you can do to make things water resistant, and there's lots of techniques. We do have some tutorials and more, and there's lots of things you can do.
Yeah.
That's what I would suggest.
I mean, you're never going to have a waterproof Arduino. You'll always have to put in an enclosure, and we have some waterproof
Yeah.
enclosures, but it's like making something waterproof takes a lot of
You're going to show other
effort.
stuff over here?
Maybe I'm going to
Okay.
see if this one.
All
is the
right.
brightness I want.
Next up, how do you calculate how long a LiPo battery will run a feather?
Well, it depends on what feather, because if it's a like a Wi-Fi feather or an ESP feather, it's going to draw a lot more current. The right way to do it is to measure the current draw with a multimeter or a like an INA 219 or whatever to get the current draw. And like, you know, I have this like a fancy current meter that actually gives you like USB data plotting, because if you're having little spikes of current, you might, you need to measure the width of those spikes. So it's actually not easy. Oftentimes what I suggest is just take a small battery, a rechargeable battery, see how long it lasts, and then divide it by the hours to give you the average milliamps.
Okay.
Draw. So this is the example of this is only at like 3 volts, and this is the white LED, and it's just like, it's blinding. So this is non-diffuse, so it doesn't show so well from the side, and from the front it's just like crazy bright.
Yeah.
So that's
You don't
why-
want to switch to blinded. You want to be operating your switch.
Yeah, you don't want to be blinded. So,
Okay.
yeah. samples.
Would you make something like the Arduino IDE for an FPGA? That's a project.
I mean, no, it actually doesn't make sense really to do that, because Arduino, the IDE itself is actually not what's interesting about Arduino. It's the core libraries that just work. And with FPGAs, it's like it's not the same, because like you wouldn't really rewrite those library core. I mean, it's like it's not a microcontroller, so you wouldn't be able to port all of those functions. So, I mean, it would be cool if somebody made like an easy to use FPGA generated, but the thing is, the people who do FPGA, they're willing to spend a couple $100s on a dev board because they want really, really good timing for whatever application. So they're not going to be that interested in a low-cost kit. Does that make sense? Like microcontrollers got to the point where they were $1 or $2, so it made sense to make a $30 dev board. But with FPGAs, like you can't really get started for less than like $500 really. You can get like a $100 dev kit, but like it's very minimal.
Next up, I'm working on a parabolic solar cooker that tracks the sun. How would I time it so that it would follow the sun? So I think they mean movement.
The best way to do it would be to maybe use a magnetometer and a GPS, and you know where you are, and then you can always point at the sun. I mean, that way you don't have to do any sensing.
Okay.
Usually, what people do for solar cells, like with MPPT, MPPT, is you can move it back and forth a little bit and just see like, if you oscillate it slightly, you can see how your current draw increases,
and then
you move in that direction. It's kind of like what sunflowers do.
Yeah.
It's tougher with the solar cooker because you're not measuring that current draw.
Yeah.
You actually just have a lens. So honestly, the only thing I can really think of, other than like a mechanical system, is to use like GPS and a magnetometer. You know where you are and which way north is, and then you just plot how to move. Kind of overkill, but it would work.
All right. Okay. That's going to be the question for tonight.
Okay.
Because we want to do a giveaway.
Yes.
So thanks, everybody. If there's any other questions, of course, post them up in the forums. It's our customer support forums. Be able to help you out there. And let's give away something.
Yeah.
What do you want to give away?
We're going to give away an SP32
Wow.
Rover.
That's a big deal. Okay.
Yeah.
So let's show it. So we're giving away one of these.
Yeah, good for developers of the ESP32.
Okay.
You love hardcore microcontrollers with Wi-Fi, Bluetooth built in.
Okay.
This is what you want to get. So we're going to give away one of them.
Okay.
Not a toggle switch.
What are the rules to the trivia question?
The
Lynetta?
rules are, if you've won before, you can't win again. Only one winner per my lifetime. The first person to answer the trivia question that Mr. Ladiata asks in the correct spelling and form that he wants it wins the prize.
Okay.
We'll be checking the multiple chats. Whoever we pick is the winner.
Okay. I'm going to ask a trivia question. we celebrated the anniversary of our electronic coloring book, and in the chat room, for the letter Q, what did it stand for in the coloring book? The letter Q.
Yeah.
What did it stand for?
Yeah.
It wasn't John Delancey's portrayal of Q, the omnipotent being in Star Trek Next Generation.
It wasn't, but what was it?
But what was it?
Q. Q's a tough one.
42 is not the answer. Geordie LaForge
You
is
can
not
also
the answer.
maybe
Blue
guess.
Whale is not the answer.
Like if you had an electronics coloring book and
Yeah.
Q had to stand for something.
You can go to our page where the
book.
coloring book is and figure this out. It's not too hard. Do. Quotient? No,
Good guess.
not bad. If you go to, I think, adafruit.com/coloring book, you can eventually find it.
Q.
And Stereo Matzel, congratulations in the YouTube chat.
Close enough.
You got it. Quartz. Yeah, I'm fine with that.
It's tough to spell.
You won. I know what you meant. All right, so Stereo Matzel, email support@adafruit.com and tell them you won PID 3384. So,
Quartz.
yeah.
Q.
Yeah,
Q1 on most schematics.
you won. So email support@adafruit.com and it's product ID 3384 and they'll help you out. Thanks for playing.
Thank you.
Okay, that's our show for tonight, everybody. Thanks for joining us on the internet.
It was a ride on this internet. We rode this like internet buggy.
Yeah. Okay. All right. Thank you, everyone who is part of the Adafruit adventure. All of our community, our fans, our customers. Don't forget the code is Toggle. Gets you 10% off the Adafruit store all the way up to 11:59 p.m. Eastern Standard Time. You got to do it. Do it. That helps pay the bills and more around here. So maybe consider it.
Okay. Thanks, everybody.
Yeah. And we'll be back next week and more. And don't forget, trailer.
You got this trailer?
Yeah,
All right.
that's what I'm going to do. I'm going to do this little trailer.
Okay, everybody, hold on.
Okay, and we've got, that's the code. And I'm going to do the little exit trailer thing.
Cool.
Here's a picture of a cat.
Meow.
Here's your moment of Zener.
Meow. No. One Direction. Close up.
Yeah. Okay, bye, folks.
Later.